Hi, my name is Allison George, and I'm a math teacher at R.J. Reynolds High School in Winston-Salem, North Carolina. I started teaching at Reynolds in 2003, and in 2007 we received a federal grant to become an arts magnet school. Our school reform model was arts integration. So what we do is we integrate the arts into all of our core classes as often as possible. This has helped, employing this model has helped with our discipline rates, it has helped with our student achievement, and it has helped so much with student engagement in all classes. And so what I wanted to do today is I have been working with the North Carolina Museum of Art. They have an MC Escher exhibit going on right now. And so what I wanted to do is show you one of the ways I'm going to integrate MC Escher into my Math 1 classes, or Algebra 1, depending on what your school calls it. Alright, so the first thing I have is I have found this painting, or this etching actually. It is from about 1920, when MC Escher had gone to the Netherlands. It is the inside of a cathedral named St. Bavo. At the North Carolina Museum of Art, they have a slightly different sketch than this, but it was all done at the same time. And what I'm going to do is use this. I am currently in the middle of my linear equations unit, and so there's all kinds of different ways I can use this painting to explore all different kinds of lines. Generally, MC Escher is used to discuss tessellations and things like that, but he has a lot of different things that you can do. So the first thing that I did is I took a grid in Microsoft Word and overlaid it over top of the painting. So we've now got an XY axis or coordinate plane that we can use. In the links, I will add an address to a tutorial for this, so you can see how to do it if that's something you're interested in doing. And then I went over top of to make my x-axis and my y-axis using a Sharpie. So the very first thing that jumps out at me with these are all the different kinds of lines that you can see in there. I am gearing this primarily toward Math 1, so this could be applicable anywhere from 7th grade, 8th grade, 9th graders. So there's the basic horizontal line right here that you could address. There's also one here, bottom of the windowsill right here. And then as you get into individual ones, there's lots. So you can discuss with your students how to write the equations of these lines. So for this one, it crosses the y-axis at -7. So we'd have our y equals -7. You could get into a discussion about why x isn't included in that line. All different kinds of things. You can use this as however, as a jumping off point for whatever you need to discuss. So those are the horizontal lines. You can also use these to discuss slope. You can pick any 2 points on a line and use that to go over calculating your slope. So for example, this whole line right here goes all the way straight down. And you're going to have your students do tons and tons of practice problems with slope anyway. Might as well have them do it on something fun that they enjoy. They can color, use highlighters however you want to go through and use those 2 points, plug them in, and calculate the slope of the line. You can also have them then do the opposite side and have them compare. Are they perpendicular lines? Are they close? Are they going to intersect at a 90-degree angle? All kinds of different things that you can use. You can also look into finding parallel lines. When we go right here, these are slightly off due to the nature of the copy, but in real life that would be parallel lines. You can get into talking to them about why they're parallel, what the slopes are, all of that. Then you can also get into, once you've calculated the slope right here, you could use this to employ point slope form and go through and calculate y minus y1 equals m times x minus x1, and they could use that to write their equations as well. The nice thing about this is when you start thinking about arts integration, you just want to pull it in as often as you can. And so anywhere that you can use what might normally be a boring set of examples, pull in something from this. They're going to be a lot more engaged. They're going to enjoy it. They're not going to complain about finding it. And if you can slide a little bit of background about MC Escher in there while you're working on it, so much the better. You can also talk about domain and range. For example, when we get to, switch to another copy here. So we could talk about with this one, say this line right here, it's a very short line segment. So you could calculate the equation of that line, but then you can also talk about, well, does it extend on forever, or is this a line segment? If it's a line segment, can we narrow it down to where exactly it is? Talk about domain and range. Talk about where the y's are, where the x's are. And then the other thing you could do is if you took a long line like this one, similar to the one we talked about on the other side of the graph, and pull quite a few points from that line. So pull each of these bases as they go up. If you are doing linear regressions, you could use that set of points to use your calculator to figure out the linear regression of that line and to get the form that way as well. So you can pull from one of these sketches, you can pull all kinds of different ideas. Now those are all the things that I talk about in Math 1. In higher level maths, there are circles and ellipses in the graph, in the picture right here. So we've got, depending on your angle, it either looks like a circle or an ellipse. We have a giant sphere in the middle that we could discuss and find those. You could talk about parabolas. And, you know, for example, right here, this domed arch, it's not quite a parabola. So that could be an interesting discussion with your kids about why it is or isn't a parabola. What's the difference there? And you get into higher level maths, you could also talk about, when you get into pre-calculus and calculus, talk about the area under the curve. So for example, looking at that same shape right here, figure out all of this, figure out the area under the curve for that line. Or up at the top when you're dealing with the circle and the sphere right here in the center. Find the area under that curve between the x-axis and that one. So there's lots of different places where you could employ this technique. As I said at the beginning, this has been something that's been really successful at our school. I have found with my Math 1 students, and if they're taking it in 9th grade, they are on grade level. They tend to not be super enthusiastic about math, and so using these arts integration and pulling in different examples has really been a great way to get my students engaged and get them interested, and to find out that, yeah, you really do math in all kinds of different. So thanks a lot. I hope you enjoyed this. I'm going to put some links and some follow-up questions in the rest of the TED to Ed. Please interact and let me know if you have any questions. Thanks.